Um, Welcome back. This is the third part of implementing programming constructs via data structures in the Python programming language. Let's just spend a few minutes to review what we have done so far. We have been working toward implementing the corresponding data structures for literals, arithmetic expressions, variables, and for variables, we support both referencing existing variable or creating assignments of data values to variables. And we've also implemented logical conditions and flow control via branching based on logical conditions. And all these data structures are going to be subclass of this class called expression. So the very first subclass of expression is that of literals, and it's constructed by just specifying a value. And the evaluation of literals given a particular context is just the value that it was constructed from. And so here's an example of constructing a expression which is a literal of the value 3.1415. We can evaluate it with just a empty context, and we get the result of 3.1415 as the result of the evaluation. Next, it's arithmetics. Here, what we have is a set of arithmetic operators that we support, plus subtraction, multiply, and division. And the construction of arithmetic operation is done by the specifying the left operand, the operator, and the right operand. We save these as part of the data structure. And when we perform the evaluation, we look up the function that will perform the mathematical operation. We evaluate both the left and the right to be the data values, and then we return the result of the mathematical operator being applied to the result of left and right evaluation. An example of this is that should we want to evaluate 3.1415 times 10.2 times 10.2, we build a data structure like this. And the data structure is built as the arithmetic of the literal 3.1415 applied to the operator multiply with another arithmetic expression, which is the product of the literals. And then we evaluate this, and we get this result. Moving on to the next one is the variable var, where all we need is the variable name. So this is variable reference. This expression is supposed to evaluate to the current value that is bound to the symbol specified by the name. And for this, the evaluation needs to make use of the context. We do a basic check if the name does exist in the context, and then we look up the value associated with that name. Otherwise, that's an error. What is the context? Well, the context is here. So this is an example of the context where it's really just the key value pairs where the keys are strings, which represent the names of variables, and the values are arbitrary data types, data values. So if we want to look up the variable value of pi, then we would create a variable expression and evaluate it with respect to some context. So the important thing here to highlight is that when we construct the expression of the variable type, we actually cannot figure out the exact value associated with it. The exact value depends on the context. So different context, the same expression would evaluate to different data. If we are to have a context that has pi and radius, then we can evaluate this expression of pi r squared using this data structure evaluated against some context. We can also perform assign, where you can see that the assign expression is constructed by specifying the name of the variable and then the expression that you want to assign it to. The evaluation of the assign expression modifies the context by first evaluating the right-hand side expression and then assigning the to the key, which is the variable name of the value that was just evaluated. So if we want to set some variable I to 0, then this is a data structure we would construct. And if we want to run it against a particular context, we will perform this evaluation, and you can see the context then has the additional entry. We can also make use of the assign to modify existing variables. So here we have I equals to I plus 1, and this corresponds to assigning I to an arithmetic expression which corresponds to I plus 1. If you evaluate that, then the value I is the previous value incremented by 1. Moving to expressions, with if and else, the first thing we need to do is we need to construct the condition expression. This evaluates to a logical value and based on the operator. So we look up the logical condition of the operator, and then we pass the evaluated results of the left hand and the right hand operands. And our implementation of the condition expression borrows the base implementation of arithmetic in Python. You don't have to. Now, I'm going to take the opportunity to highlight the operands or the operators that we support. We support equality checking, less than, greater than, and not equal to. And what I will do is I'm just going to add a few more of less or equal to, which is the weaker comparison of less than, and then greater or equal to. Okay, right. Now, so if we have, if we want to check a condition whether radius is greater than 10 or not, then we can build a condition expression that references the value of radius and applying to the greater than predicate and compare it with a literal expression of 10. And we can evaluate this. And because the radius is 10.2, we'll see that the result is true. And from this, we're able to construct the if and else. The if and else is constructed by specifying the condition and then the if expression, as well as the else expression. The evaluation is, it first evaluates the condition. If that is true, then it returns the evaluation of the if expression. Otherwise, it returns the evaluation of the else expression. And now finally, This allows us then to build something like this that says if radius is greater than 10, we return the string greater than 10, otherwise less than 10. And so here, the construction of that in terms of data structure is we construct the if and else by specifying the condition that is equivalent to the this line of radius greater than 10. And then the if part is the string greater than 10. The else part is a string of not greater than 10. And if we run this, it says greater than 10, as it should. Now, before I go on and look at what we're going to do today, okay, so what we're going to do today is we're going to implement loop, function declarations, as well as function invocation. And we're going to have some examples that involves like loops and recursion. So that should be pretty exciting. Okay. Okay. So the first thing I would like to do is to be able to render the data structures that we construct as strings. So this would greatly help us debug any programming error that we might run into. So Python has a built-in method for all its objects called __ string, and this method will be used by default whenever a object needs to render itself to a string. So for expression, what we're going to do is we're just going to return a string that's informing that there is no way that we know of to render the expression object. So let's say string is not implemented, okay? Because this is the base class, and we expect this to be overwritten by the subclasses later on. And for a literal, it's just a value, so we can just specify the value as the string representation. And so what we can now do is, instead of just evaluating the expression, we can actually print the expression followed as a string followed by the result of the evaluation. So we can print E and the evaluate of the evaluation of E. So there you go. Okay, so the expression is 3.1415 and it's evaluated to 3.1415. Now let's work on the arithmetic. The arithmetic is really just the operator, the left expression, and then the right expression. So we're going to do it similar to like a Lisp style. We're going to specify the operator first, and then the left expression and the right expression. So here's the operator, left expression, left. And you might say, well, how is it possible we can just specify left and right? Because they are generic expressions. How is it possible that we can just print them as string? Well, because they're generic expressions, they'll all have a meaningful string function, which will then render them depending on what kind of type they are. So let's see if that works. So here's our expression. And instead of evaluating this, I will print itself as well as its evaluation. And you can see that here's the expression. It's multiplying 3.1415 with multiplying 10.2 with 10.2. Okay, and it gives you the result. So this is pretty cool. And it's going to be quite helpful should we ever run into trouble. So let me perform the same thing on variable reference. So I think we're just going to return the name of the variable as the string. So let's print the, so let's set E to be just a variable reference. And then we're going to print of E with the E dot evaluate of the context C. Oh, is it not? Oh, I didn't run this. Sorry. Execute. Right. So now pi is 3.1415. So let me just add a space. Just much nicer. Well, and we can start doing the same thing for this other expression as well. Oh gosh. There we go. Okay, so the multiplication of pi with the multiplication of radius with radius under this context is 326. All right. The assignment is done as the variable name followed by whatever expression. So we just provide the variable name and the expression, and this then allows us to print the expression with the evaluated result of the expression. I'll keep making the same mistake. So there you go. Okay, so we made the assignment, but we don't return anything. Now then what we can do is we can ask ourselves, well, is that what we want? It is actually possible that we think of the assignment as something that does return value. And it would make sense to say, well, if we have to return some value, maybe we want to return the value of the right-hand side that gets assigned to the variable. And so all we need, if that's what we want, all we need is we need to just return that value since we computed anyways for the assignment. And if we are to do that, then you can see that this expression of I equals to 0 actually becomes the value 0. In addition to modifying the context, it evaluates itself to a value. I think that's nice, so that's good. And if we were to do that, trying to copy here. Okay, if we're to do that, you see that I equals to I plus 1, and that evaluates to the new value of I, and we see that indeed the action of modifying the context has also taken place. I'm going to continue to implement the string function for condition. Well, actually, it turns out that we don't need to do that because condition is a subclass of arithmetic, and arithmetic already is able to render itself. So we can just borrow that. So we can do that. There you go. So this is the string that gets rendered of condition. So we're checking if it's greater than between radius and 10, and it is true. Let's do branching. Okay, so branching has the condition and two expressions. I suppose we should have if, and then the condition. And what I'll do is I'm going to specify the if part, followed by the else part. Okay, and let's see if this works. It's like, there you go. Okay, so it's saying that, so here's the string expression. It's if greater than of radius to 10, then say greater than 10, else not greater than 10. Okay, so that's and then the result is greater than 10. So perfect. All right, good. So we're going to continue and with the implementation of while loops and function declaration and invocation.